Hello, I work on audio and video equipment, and I suppose this is audio equipment. Today we're looking at some trussed speakers that are used with a PC, and they were starting to annoy me because I was picking up or hearing a hum from them all the time they were switched on. But this can be connection problems, it could be a computer problem. There's a multitude of different possible causes for this. So let's have a look at eliminating where the problems are not, and then work out where the problem really is. So here is the system. We have a amplifier and bass unit here, two satellite speakers plugged in here, and a remote control unit. And the problem is as follows. This is a mains or an on-off switch. It may be on the DC side of the power supply, but it's a main switch for what we're looking at. There's a bass control here and an overall volume and on-off here. So let's switch it on. And there's a small amount of hum. Let me set you up to hear that. So that's it with it on and then off. So there's this distinct difference between off there and on. And most of the noise is coming out of the bass unit because of course it's a low frequency. So that's what we need to solve. Now there's a few things we can do here. One thing is adjust the volume control. Does the volume change the hum? Well, when you wind it up, it does introduce a bit more hum, but it's of a slightly harsher sound, and that's pick up from this cable. So if I touch these, that's pick up. And it has a rather different sound to it. It's harsher than the pure sound that we're getting. So the volume is not changing significantly on the deeper part of the hum, which is the objectionable thing. And does it alter with the bass control? And the answer to that is a bit. It does seem to alter slightly with the bass control there, but not with the master volume. Now there's another test you can do, but it doesn't work in every system, which is you listen to it as you switch the power off. If the humming sound seems to remain in the second or so it takes for the sound to disappear after you've switched off the power supply, then you're looking more at a mains pickup problem, external to the unit. But if it disappears instantly, then that's because that hum is being generated from its own power supply, probably due to bad capacitor in the power supply. So let's do that experiment. So we're switching it on, and we'll switch the power off. And the whole thing seems to shut down instantly. There doesn't seem to be any lag while the capacitors discharge. And that says to me that the capacitors in here, or capacitor in here, if it's got a DC, a linear power supply, which it almost certainly has, the capacitor is very low value, I would suspect. Now, if that's a date code 0904, it's an old piece of equipment, so the capacitor has every chance to dry out. So let's see if we can take it apart and replace the capacitor. Well, test it and replace it. Now that could be a challenge because it may not be obvious how it comes apart, but I see two big screws here, but they're hot, so that might be for a heatsink rather than for the getting the whole thing apart. They do feel quite warm, very warm in fact. Looking in the port here, see if there's any clues there how it's built. Not a lot. You can see this terminal block here, the terminal screwed to the back cover. It may be that we have to go in through the bass unit. It may be that the whole unit's been designed not to be repaired and is glued together. I reckon that the cabinet's been built and then the components have been screwed in and fitted, and then the speaker's been fitted on the top, and then the cover glued on over the top of that. But I could be completely wrong and doing terrible damage. I can't feel any screws in the grill, but it does seem very firmly fastened at these points. I don't think that's glue. With enough light I can see the speaker in there, so they're the screw holes that are holding the speaker on. But it's still not obvious if I should be going in through here, because it feels like the grill is screwed on. We might be getting to the point at which we just have to force it off. Ah, they're not screws, they're clips. Sometimes a bit of brute force is what's needed. Okay, the cover's off, one of the clips broke, but that's not a biggie. So let's take these screws out of here and hopefully we'll have enough access to the internals. Yes, I think that gives us the access we need. So there's the amplifier. The thing screwed to the bottom is the transformer. I'll try to give you a view of that. So transformer at the bottom, amplifier at the top, and here's the port. So I need to get the amplifier off. I think I'll disconnect the speaker if I can. It might be glued on though. Yeah, it looks like they've glued the connector probably to stop it vibrating free. Oh, no. If there was glue, it wasn't too much. So now I can undo these screws at the back and release the circuit board. I may need to take the transformer off as well to get some room. The transformer's really rather hot. Now that's possibly telling me something. Why is the transformer so hot? It might not be capacitor trouble, it might be the transformer at fault. Unusual, but you know, things happen. There's a bit of glue holding it in place, so I'll have to just force my way through that. Right, there's the mains rectifier, and there's the smoothing capacitor. Should be 2,200 microfarads at 25 volts. So I think it's always a difficult call, this, you know. If you test it in circuit, you get slightly skewed results by the circuit. But if you desolder it, you can get skewed results because heating it up can change its value. I find that all the time, actually. And I keep going on about it. I've got remote control operation of this ESR meter, so I can operate it with a foot pedal. It says 2,400 microfarads, so the capacitor is not at fault. But I think, judging by the heat of that transformer, which is still really hot, that's where the problem lies. Where could I get another transformer? Let's see. It says input 230 volt 50 Hertz, output 10 volt 1.5 amps. So I have to get another 10 volt transformer from somewhere. Well, maybe I can. Let's measure the voltage that we're getting from that. We're getting about 12.5 volts. And the transformer's buzzing. Let me unplug this load. Yes, there is a bit of glue on it. And see if it buzzes still. Yes. I would say the transformer's at fault. I'm wondering where there's a fuse. There must be a fuse in here somewhere. Well, the amount of hum coming from that now is acceptable. And it wasn't before. We do like inconclusive results, don't we? Well, I have very inconclusive results. And I'm going to take a guess that what's going on with this extremely hot transformer is that it's leaking a magnetic field which is being picked up by this amplifier. And don't think that transformers can't do that, because I've seen it. I had that problem with an oscilloscope once. So I'm still looking at changing the transformer, I think, or modifying the unit to take an external power supply. That might be a good idea, since it's got about 12 volts going in anyway, so it wouldn't mind if it took 12 volts from an external power supply. That might be the simplest workaround for this, mightn't it? I'm not happy about leaving that transformer in use when it's getting, I wish I could show you how hot that is. I think that's dangerous, and it's certainly wasting energy. So I'm not going to use that transformer anymore. Right, so the safest thing to do probably is to fit an external DC input socket and arrange an external power supply for it. Okay, I've set it up with an external 12 volt power supply. I've got hundreds of them, I'll show you that in a moment. So let's just power that up and confirm that it seems to work. That was interesting. Lots of hum from the external speakers. But not from the internal. Oh, that's volume controlled, that hum. So that's just pickup from this mess. Okay, don't worry about that. So I just need to hook up a way to connect this power supply to the speaker unit, and there's the power supply. I collected dozens of these from a business that was sort of closing down. Right, let's hook that up then. Okay, so I've wired up. These have got these connectors that we used for applying different types of plug to them. In this case, I've used one that I'll never use for anything else. It's a really stupid, tiny barrel connector. So I've soldered wires to that. Of course, the polarity doesn't matter because there's a rectifier here anyway. So we'll just check that that still works. Bearing in mind that we may get a little bit of hum at higher volumes, but I'm not too worried about that. I think that'll disappear when the input signal is connected up properly. Okay, so let's power it up and see what we get. The light's on. If I increase the volume enough, we can just about hear some hum on there. On the speakers, where's the input? That's as you'd expect. I'm absolutely delighted with how well that's worked out. Right, let's reassemble it. Good, that's all working. Now I'm going to, when I go downstairs, I'll put this in test, make sure I'm happy with it. I'll cut off the old mains lead and label up this as 12 volt AC or DC input. So what started out sounding like a minor annoyance could potentially have been a safety issue. I didn't find a fuse in there. Now there could have been one in all the gloop that's associated with the power switch, or it could be there's just a thermal fuse inside the transformer. But given how hot it is, why hasn't it failed already? So, well, leaving your opinions below. I think that was a safety hazard. What do you reckon? Do you think that was dangerous? Anyway, I'll do plenty more content on audio and video technology in the near future. Bye for now.